Hello, Algebra 2! Hope you guys are having a fantabulous day. Okay, so today we're dividing polynomials. Yesterday, or last class, was multiplying. Okay, so here's the deal with the dividing, right? I'm going to do a little quick review on long division. So if you feel comfortable with long division, then you can skip the next couple minutes. And then move on, you can skip to when I start doing the actual polynomial division. So I give you permission to do so. I won't ask any questions about the next couple minutes. But yeah, you need to know how to do long division. So if this review isn't enough for you, make sure you come in office hours or do some practice online or something. Okay, so long division, right? Remember, when you set up your long division, you put the dividend, which is the thing being divided, 524 in this case, on the inside of your little half box thing, and then your divisor, which goes on the outside, up there. That's the thing dividing into the dividend. Oh my gosh, too many words. Anyways. So, you know, your first step is to try to figure out, okay, how many times does 3 go into the first number? Okay, well, 3 goes into 5 one time. So we put a 1 up top, right? And then, you know, as a reminder, you can put like a little multiplication symbol there, because then you do 3 times 1. Okay, so I'm going to erase that. So then I do 3 times 1, and I put that down here. 3. Subtract them. 5 minus 3 is 2. Okay. Then you got to bring down the next number, which is a 2. And then you start over with that new number, which is 22. So then you figure out, okay, how many times does 3 go into 22? Well, it goes in 7 times, right? Because 3 times 7 is 21. So that's the closest we can get without going over. So 7, that goes up top. 3 times, so then you do the 3 times 7, and that goes below the 22. Subtract, and you've got 22 minus 21 is just 1, and then you bring down the 4, which is, your new number is 14. So then you want to look at, okay, how many times does 3 go into 14? Well, 3 times 5 is 15, which is too many, so 3 times 4 is going to be the closest you can get. So that 3 times 4, so then we multiply 3 times 4, and we get 12, subtract, and I've got a 2. So then my remainder is 2, right, because there's nothing else I can do. A lot of times, right, we learn to add a decimal, add a 0, and then keep going, right, until you see that it's a repeated decimal, or until it stops. But actually, for the purpose of the polynomial division, we want to know the remainder, okay, because then my final answer, actually, because remember, I like fractions, not decimals. So your final answer is your remainder, which is 2, divided by or over the divisor, which makes sense, right? Because we were dividing the whole thing by 3. And so my remainder is 2 divided by 3, whatever that is, right? 0.6 repeated. Okay, so then my final answer is 174 and 2/3. Okay, so that's my final answer. So we're going to end up doing the same kind of thing, but with polynomials. All right, we are going to move on to polynomial division. So if you skipped through, you should be joining us now. So you set it up the same way you do long division. Okay, you put your dividend inside the long division symbol. Okay, so I've got my 5x squared. Oh, I need more room than that. Still need more room than that. Okay, 5x squared plus 2x plus 4. Now, something to keep in mind. Had this been a 5x to the 4th plus 2x plus 4, you got to have placeholders for every term, every degree below the highest term, the highest degree term. So if it was a 5x to the 4th, I would need to, inside the box, I would need to have 5x to the 4th plus 0x to the 3rd plus 0x squared plus 2x plus 4. Okay, so just so you know, for future reference, if it skips some terms, then you have to, you got to include those placeholders. Okay, we do not have that right now, so I'm just going to leave it as an x squared, 2x plus 4. Okay, that goes inside the box. And then I've got that x plus 3 outside. And now you want to look at the highest powered terms, the highest degree terms in each polynomial. So you want to strictly look at the x and that 5x squared to start. And you just want to find out, okay, how many times does that x go into 5x squared? Now, when we end up multiplying like regular division, we multiply by the whole thing, x plus 3. But to figure out how many times it goes in, we just look at the highest power. Okay, so how many times does x go into 5x squared? Basically, what do I need to multiply x by to get 5x squared? Well, 5x, right? Because if I multiply 5x times x, I get 5x squared. Okay, so then once I do that, then I take my whole divisor and I say, okay, that times 5x, and I write it down as, 5x times x, which is 5x squared. And then I do 3 times 5x, which is plus 15x, okay? And then, just like we did in long division, we subtract that entire thing. Now, keep in mind, you're subtracting all of it. That's a huge subtraction sign, okay? So don't forget your subtraction. Okay, so I've got that 5x squared minus 5x squared, so that's 0x squared. And then I have 2x minus 15x. Okay, so it's at negative 13x. Okay, then I take the 4, bring it down, plus 4, and then that's my new dividend. That's the new thing that I'm looking at. So then I kind of just start over. Okay? So then, oops, too much. Too much. Okay, so then I look at how many times does x go into negative 13x. Again, remember, strictly the highest degree terms for now. Okay, how many times does x go into negative 13x? Negative 13 times. Okay, because x times negative 13 is negative 13x. Then you take the entire x plus 3, multiply it by negative 13, and I end up with negative 13x. And then I have that 3 times negative 13, so that's minus 39. Okay, and then I subtract that entire thing. Negative 13x minus 13x. Okay, those cancel purposefully. And then, so that's 0x. And then I do 4 minus negative 39. So that becomes 4 plus 39. Minus a minus is plus. 4 plus 39 is 43. And then I would start over again. I'd say, okay, oh, well, bring down the next term, but there is no next term. Die. Okay. So then I would bring down the next term. There is none. Can x go into 43? No. So, that's your remainder. 43 is your remainder. So just like we did in long division, my final answer is whatever my quotient was plus my remainder over x plus 3. So my final answer is 5x minus 13 plus 43, which is my remainder, over my divisor, x plus 3. Okay, so that is my final answer. Done. All right, let's move on to the next couple examples. So again, there's 4 examples. I'll talk you through whatever I have time to talk through, I guess, because I have like 15 minutes for the video. But again, I'd recommend just trying it, seeing if you can do it on your own, and then looking back at the video and looking back at the answers. It's a good check to see whether or not you get it. All right, go ahead. Pause. All right, example 1. Set up your division problem, dividend on the inside, okay? 2x, how many times, so again, you want to look at the highest terms. How many times does 2x go into 10x squared? And that would be 5x times, because 2x times 5x is 10x squared. So that goes up here, 5x times. So then you take the entire thing, 2x minus 1, multiplied by 5x. So then you get your 10x squared. And then you still have to do that minus 1 times 5x, so minus 5x. And then subtract the whole thing. 10x squared minus 10x squared is 0x squared. And then I've got 13x minus negative 5x. So that's negative 13 plus 5. So that would be negative 8x. Bring down the plus 2. And then I start over. And I figure out, okay, how many times does 2x go into negative 8x? Well, what's 2 times what is negative 8? Hopefully you got that. Negative 4. So then I have a negative 4 up here. And then I want to take that entire 2x minus 1 and multiply it by negative 4. 2x times negative 4 is hopefully negative 8x. It is. And then negative 1 times negative 4 is positive 4. Subtract. 8x is cancel. 2 minus 4, negative 2. And then at this point, right, we have 2x going into negative 2. That doesn't work, so we're done. The remainder is negative 2, so I've got that minus 2 over 2x minus 1. And that would be my final answer. All right, here's the answer to number 2 for you. This is an example of one where you have to put a placeholder in, right? I needed to put a placeholder in for x, the x term, x to the first. And you kind of see as you do it, right, when I plug that in, then all of a sudden this 0x and the negative 4x, those line up nicely. And then, you know, things are nice and neat. And turns out this actually goes in evenly. There was no remainder. So your final answer is x squared minus 4x plus 4. Now, number 3 is kind of interesting because you can do this the same way. You can do it with long division. Make sure you have your placeholder for the x to the first term. Or, if you think about it, right, division and fractions are the same thing, right? So this is x squared minus 1 divided by x minus 1. That's the same thing, whoops, trying to zoom in here, as x squared minus 1 all over x minus 1. And if you think about it, x squared minus 1 factors, because it's a difference of 2 perfect squares, to x minus 1 times x plus 1 divided by x minus 1. So actually, kind of a cool thing, cool little trick here. X minus 1 is a factor of both, and so my final answer there is just x plus 1. But you can do it the long way too. And lastly, number 4, the answer is x minus 2 plus negative x plus 3 over x squared. Cool. All right, that's it. See you later, friends.